But when I do this, okay, I don't understand green screen, apparently. All right, so what we've been working on so far is if somebody scores above, what percentage of people are scoring above, what percentage of people are scoring below. I want to review something about those questions. Go back to your notes and notice the IQ of, what was it, 80, I think was the low one that we worked with. And I believe the question that we looked at was, what percentage of people have an IQ below 80, given the standard deviation of 16 and the mean of 100? And our answer, where'd it go? Our answer was, what, 10.56% is what I have in my notes. So I wanted to remind you that I'm also talking about percentiles as another way to describe this. People talk about if somebody scores in the 40th percentile, then blah, blah, blah. And so that's just language around z-scores. So one way to describe a z-score is to say, what is its percentile rank? And its percentile rank means what percentage of people scored below and up to that score. So the percentile rank of an IQ of 80 is, you can write 0.1056, or I will accept 10.56. People talk about it in both ways. And then what's the percentile of an IQ of 132 was the other problem that we did. And 132 is above the mean. It's going to have something greater than 50 as its percentile rank because it's above the mean. So we got the 50% from below and the 47.72% from above gives us 97.72% of people have an IQ below 132. So the percentile rank of an IQ of 132 is 97.72. It's just another way to answer the question and to use the language. It's the same math, it's the same issue. The difference is language and only language. So when I say what percentage of people scored below, I am asking this exact same question as, what is the percentile rank? Okay, so now you have a definition for percentile rank. You know how to get it. You just look at the percentage of people who scored below. Any questions on percentile rank other than I don't understand z-scores? Help me, please. Okay. I want to show you how we do a few different problems. Did we do what percentage of people have an IQ above 125? Have we done that problem yet? Yes. Well, yes, we did that one. Okay. And have we done what percentage of people have an IQ above 90?
No.
Let's warm up with that one. It's a pretty serious eye you got going there, Isaac. Okay. So what percentage of people, hold on, I have got to get the pencil down smaller. What percentage of people have an IQ greater than 90? This is just another way to, just another example of the same stuff that we've been doing. I'm going to go on from here to do slightly more nuanced questions, but I just wanted to warm up with this one. So we draw the curve and we put the 100 in the middle. And then we figure out where to put the line for 90. 90 is below 100, so I draw a line anywhere down here, it doesn't matter, and say x equals 90. And now I shade in what I want. I shade in what I want to know, which is what percentage of people score above 90. So what I want is this whole yellow section. We cannot get anywhere finding section under the curve until we have a z-score. We either know the area under the curve and we find the z-score and then turn it into a raw score to answer a question, or we have a raw score, we have to turn it into a z-score and then use that to find that area that I shaded in, or part of it at least. Okay, so first the z-score. So z equals score minus the mean divided by the standard deviation. And we are using the same mean and standard deviation, 116. So z is equal to 90 minus 100, and divide that by 16, and somebody tell me what you get.
It's negative 0.63 if we're rounding up.
Yep, that's
625.
Yep, I get the same thing, Heather. Any questions so far? Other than, how did you know what step to do? How did you know what step to do is a system question. I understand if people have that one, but I'll get to that. For those of you who are really lost about the system, you're just going to have to try to grok it. It's logic. If I have this and I have that and I need this other thing, what do I have to do to get there? So you can't just memorize. You have to actually understand what you're trying to obtain and what your tools are, and in what order you should use them. And it all has to do with what you have to begin with. And you must draw the curve so you know what you're doing. Okay, so now we have a z-score of negative 0.63. What the heck do we do with it? The z-score is one column. The area between the mean and z, which I will now highlight in a different color so you can see, the area between the mean and z is that. There's no area that covered the whole yellow section. There's nothing on that table that covers everything above a negative z-score. Okay, so that's not really a problem because we already know what that half of that curve is there. We already know that this is 50%. So we know that the answer is going to be 50% plus whatever that green area is, whatever that group of people are. So we go to the table and we find a z of 0.63. How do I lose a whole z table on a little desk? Under the big clipboard that I was waving around, of course. Joe, you got the z-score negative 0.63. What's that green area?
Yes.
Joe, what is the green area in the picture?
Sorry, I had to take an important call. That's why I went off video. I'm sorry.
All right, we'll go with Elijah.
Thank you.
It's 0.2357.
Yeah.
It's a 23.57%.
Yeah. Okay. So for those of you playing along at home, you have to remember to round, right? So it's that area is, I'm going to put it in percent just to match the other one, Elijah. So we got 23.57, you said?
Yes.
Okay. So now we have 50% for the yellow part and 23.57% for the green part, which is going to work. We want to know what percentage of people score above 90, and we have both parts to the answer. So we add 50 plus 23.57, and we get 73.57. What is that? 73.57% of people have an IQ above 90. Any questions about this problem? How did I know what step to take? How did I get that number? I'll take any and all questions. Now's your big chance. Think of it as a tutorial, ask your questions. Hey Grace, are you playing along at home or are you just recording?
I'm just kind of recording right now.
Okay.
I'm really.
No, it's fine as long as I know. That way I won't wake you up. Go ahead, watch the recordings later. Okay. We're just gonna do 2 more. So this next one is, these 2 are gonna be like, what percentage of people scored between 2 scores and what percentage of people scored beyond 2 scores, above and below. Why would this ever come up? Well, say you wanted the middle something percent of people because you only had room in a classroom for that many people to do your experiment, and you want the middle people. You want people who feel closer to the average about some issue. Or in many social psych experiments about attitudes, for those of you who were in the last class, we sometimes want to get the people with the strongest attitudes in one direction and the people with the strongest attitudes in the other direction and skip everybody in the middle. Now we know we have 2 distinct samples, something like that. And so this is how we solve them, is with these standard scores. To be honest, we let the computer do the work, but if we do that, then you won't have a clue of what we're doing. So we're going to do it ourselves first. Okay, so we're going to stick with IQ here, and we're going to go with what percentage of people have an IQ between 90 and 120? Draw the picture. I'm going nice and slow here. I've shown you what the answer to the question is. What percentage of people have an IQ between 90 and 120? We can't just get that in one go because we have no column that does that. So we have to break it down And we have to find the area between one score and the mean and the area between the other score and the mean, and then add them together. So in other words, I have to get this brown area here, and I have to get this green area here. And when I add them together, I'm going to get the yellow area that I need. We've already done part of this problem. We've already got the answer to between 90 and the mean. We did that in the last problem. So since we did that in the last problem, we got 23.24%, right? Anybody check with me if I got the right number.
23.57.
Thanks. 23.57% is the brown area. Now the green area, do we already have that number from another problem? I don't think we do. In any case, it's not that hard to do. We're going to get z equals 120 minus 100 over 16. So z is equal to what?
1.25.
Yep, 1.25. Thanks, Elijah. I don't get to see you, but your voice is really recognizable, so that's good. It's got a little bit sounds like Isaac, but I've learned now. So you're my ghost guy, and you're kind of like a go-to ghost guy, if you don't mind. Okay, so we've got a z of 1.25, and you look that up in the table to find the area between the mean and z. That's that green area. And
39.44%.
0.44, yeah. Okay, so that area is 39.44%. And if we add the brown area and the green area together, we're going to get the answer to the question, what percent of people have an IQ between 90 and 120? So now, before you did the math or after, in any case, look at this picture. Notice that the bulk of people are between those scores. There's a lot of the curve is contained in there. And a really good normal curve would have even more people contained in there. It's just a bad drawing. So we add these up and we should get a big number. So we add them up and we get, at least half of the people are contained in there. So we get, anybody else get that? Did I add it wrong? Did I add it right?
I got that.
Oh, that's good.
Me as well.
Okay. So 63.01% of people have an IQ between 90 and 120. And don't forget, these are real numbers. This is a real test that really exists in the world. When you think about the IQ test and you think about people and IQs, it makes sense that 60-something% of people should be within 10 points in one direction and 20 in the other. By the way, genius level is considered at 150. Just so you have a reference. All right, that one isn't so bad. You just have to add the two areas together when you have one below the mean and one above the mean, then the table's great. Column B is your friend. But let's do one more. What percentage of people have an IQ between 110 and 125? there's my picture, and there's the answer. Not the real answer, but I like to make pictures like this because it really helps. When I was learning it, this was like a lifeline. So let me just put the question here so we have it in the notes. What percentage of people have an IQ between 110 and 125? Okay, this one's tricky. There's two ways to do it, equally easy, just depends on what your brain prefers. And some people are looking and going, this is not solvable. There is no column that does that. None of these columns show you between two z-scores on the same side of the mean. None of them. So you have to think carefully. If you can tell the difference between z-scores and the mean, you can extrapolate this answer using some subtraction. But before we can do anything, we need the z-scores. So 110 should be really easy to get, by the way, because don't forget, we have 90. No, it's a symmetrical curve, 10 points away from the mean in either direction should give us the same z-score in reverse. So the z for 110, the z for 90 was negative 0.63, and the z for 110 should be 0.63. You can go ahead and do the math, but it's basically already done in your notes. I thought we had already done 125 earlier. That's why I like to use it. Let's see. One of the very first problems we did, we had to compute the z for 125. So it's 125 minus 100 over 16. And z comes out to be 1.56. Those we already knew from other problems. Or you use the formula z equals the mean, x minus the mean, put that over s. Either way. Dry throat today. Okay. We know these z-scores. We still don't have a column that says between these two z-scores, it's this area. Can you imagine how big this table would be if we had to do that for every z-scores, for everyone? This column would go on, it'd be as big as a textbook, bigger, I think. So instead, we need a method. Who's got a good method for how we can solve this? Who's got, tell us the logic of what you can do.
Could we just find in column B and subtract it and then get the percentage that way?
Yeah, but give us a little more detail. I'm sure you've got it right, Heather, but give us detail. What would be the first step?
I calculated found the percentage for both of them away from the mean and then just subtracted the two numbers.
Yeah. Okay, let me see if I got this right. You got this area here between this whole area in green by using the z-score of 1.56, right? You're muted again. Stay unmuted.
Yes, right.
Stay unmuted for a while if you can, unless your son is with us.
Oh, I got a shit show of my son and my husband and
Okay,
everybody's
okay.
talking.
All right,
so
all right.
I'll go back and forth.
Clicking in and out. Okay, so the green area is equal to, what area did you get for that, Heather?
So for 125, I got basically 44%.
Okay, so you get 44% of the curve is between 125 and the mean of 110, of 100. And then you said you got the other one and then you subtracted. So let's get the other one. We'll call that brown. And so for that one, you got this area right in here, correct? And what did
Yeah.
what did you get for that area?
And so that would be 24% is what it would round to.
Yep. Okay. So you get 24% for that area. Questions so far? No questions so far. And then you subtract them. You subtract the area that you don't want. We don't want that area between 110 and the mean. We want the area between 110 and 125. So if we subtract the area that's in brown, then we will be left with the area that is in yellow. And for those of you who are rounding a little bit with a little bit more finesse, you're gonna get 20.49%, something like that. I'm fine with it rounded to this level. Okay, so the way that you get them on the same side of the mean, one method to do that is to subtract. Did anybody use a different method? Hey, Elijah, did you do it this way?
Yeah.
Okay,
Heather's way, yes.
yeah. How about you, Isaac, Sam, Joe? Anybody use a different way? I'm not going to confuse you with other ways if this works. Okay, then that's what you do. That's how you figure it out. All right, we have other questions that people have gone with, and that is like what percentage of people are excluded? Have any of you in your readings come across the expression confidence interval? There's a confidence interval of. We're going to study them, I think probably next or close to next. And I might do probability first, but a confidence interval is when you say the candidate had a 45% approval rating, give or take 5%. And what we mean by that is usually it's 95%. We're 95% sure that their approval rating is somewhere between 5% below and 5% above 45. So we're 95% sure their approval rating is between 40 and 50%. We create confidence intervals because we want to be pretty sure when we give a number that it's measuring what we think it is. So we go with central tendency, the mean, and we do give or take a certain amount. And we typically want to be 95% sure about numbers that we give like that. And confidence intervals used to just be sort of like a side topic in stats. I had stopped teaching it for years, but now journals are asking researchers to provide confidence intervals for their means. How sure are you that that's the mean? Well, the confidence interval is X to X, X to Y. So the idea of confidence interval is what we're going to kind of move into a little bit here. Let's try it with a different mean and standard deviation to get you in practice. Let's say that we have a mean of 50 and a standard deviation of 3.75. And this is a politician likability score. Okay, so the mean likability of politicians is 50 and the standard deviation is 3.75 on a particular scale that somebody developed to go around a mall asking. And so we want to find what we call the 95% confidence interval for this. There's other ways to do it that you're going to learn later, but we want to find the scores that cut out the outermost 5%. We want to find the innermost 95% of scores, or scores that contain the middlemost 95% is a way that it's been said. So what scores define, I suppose is a good word here, the middlemost 95% of scores. Given that mean and standard deviation, we draw the picture. Now notice, by the way, this question is asking scores. What scores do something? Not what percentage of people do something. We give you the percentage. The middlemost 95%. We need to get scores from that. So we're going to be doing things in reverse than we're used to. So here's the mean, which, as we said, was, oops, I didn't write it down, 50. Okay, so there's 50. We want the middlemost 95%. When you want the middlemost of something, you have to cut out the outermost of something. And if you want it in the middle, you're going to have to cut out the same amount as on the top as you are from the bottom. We need these numbers. But how do we know how to get to those numbers? The answer sort of is in the question. We want the middlemost 95% of scores, which means we want to cut out the outermost 5% of scores, but we need to split it in half so we account for both outside edges. That way we're still balanced around the middle. So out here, what percentage should be out in this area? Anybody? You don't need a table.
2.5%.
That's right. 2.5% we want out there, and we want this to be the same, 2.5%. We want to find the score. We have the area. We have to do things in reverse of what we've been doing. Don't forget, you have to figure out what you want and figure out what the tools you have to get there with between the table and the formula. The first thing we're going to need to do, well, what we really want is x, and we know how to find x. It's x equals z times the standard deviation plus the mean, which means x equals z times 3.75 plus the mean. That'll give us the one above the mean. To do the same thing on the other end, we subtract the mean. You'll see it's going to work out because that z-score is going to be negative and it'll be the same thing. So subtract it from the mean is what I should say. Okay, so in order to get to that x equals, we know the mean, we know the standard deviation, but what we don't know is the z-score. And I apologize because I didn't mean to write mean there. I meant to fill in what the mean is, which is 50. Okay, so in order to get to those z-scores, we have to use the table. We know we're looking for 2.5% on the outside edges, or 0.025 is the other way to say 2.5%. In table talk, it's 0.025. What column should we be looking in to find that 0.025? Joe, do you have any idea? No. Okay. Sam?
Sorry, can you say the question again?
In what column should I be trying to find that 2.5%, 0.025?
The column farthest to the right.
Yeah, which I like to call column C, just to keep it simple for me.
Column C.
First table I ever had as a student had them labeled A, B, and C, and it made things so simple. Okay, point, what? Say it again.
Oh, I said the table that you gave us is labeled A, B, and C.
Oh, that's interesting, because the one that I'm holding here, is not, so that's good. So column C. And we're looking for 2.5% turned into decimal, so it's 0.025. We're lucky because we have it exactly. We don't have to interpret. So what is the z-score associated with that outermost area being 2.5%? Heather's like, do I really have to answer again? Yes, apparently you do.
No, my fire alarm just went off because my husband made lunch. So that's why I'm
Oh
laughing.
my God.
Is it 1.96?
Yeah, it is. Thanks. Was that Isaac or Elijah?
Elijah.
Thanks,
Well,
Elijah.
actually, so I did something wrong because I got to 2.81.
Let me just look at 2.81 and see what it looks like. I have a feeling you might have been in the wrong column.
So I'm in column C, and you know what I'm doing? I know what
Oh,
I'm
you added a 0.
Yeah, I added a 0. That's
Okay, that's not bad then. You just have to remember to move the decimal over 2 spots.
Mm-hmm.
Okay, so 1.96 is this z, and then we need the negative 1.96 for the bottom one. All right, I'm sorry for crowding this in here. I should have shrunk the screen so I could fit more. So I'm going to do the math for each one of these kind of up around the curve. So x equals negative 1.96 times 3.75, get that and add it to 50. And over here, x equals 1.96 times 3.75 and add it to 50. You guys work on that one and tell me what you get, and then we will have the answer to the question. All right, that should be enough time. Isaac, I think I saw you looking like you finished. What did you get for the bottom number?
The bottom number, I got 42.65.
So did I. And what did you get for the top number?
57.35.
Same. Okay. So what does this all mean? We have a politician's likability scale that we set up. We built it. The mean is 50. We built it that way. And what we now know is that 95% of people's answer on the likability will be between 42.65 and 57.35. So if 95% of people are in there and we're looking for people who have extreme views, then we're looking for people whose scores are below 42.65 or above 57.35. Now we have our 2 groups with extreme views. which we may or may not want. This is just an example. So, but you could use them to populate an experiment that you do where you're trying to manipulate people with extreme views. Or anything else like that. You could ask their opinions about things. If you're trying to appeal to the more extreme voters, to bring them in toward the middle so that you know, a middle type conservative or a middle type liberal could appeal to them, you can figure out what their attitudes, what their political leanings are by targeting those groups who scored specifically above or below. It allows you, when you put numbers to this stuff, it allows you to make more precise measurements, more precise guesses even, and it standardizes things. Because even though our score, like let's say I created this one, and let's say you, Elijah, created a different one, and your mean is actually one that's at 100. But we can standardize it all by coming up with the scores that are that 95% of people scored between. And we can do that because we're going through z-scores. So it standardizes it so that even though our numbers will be different, we know that above and below those numbers, we will be capturing the right percentage of people, even if the scores are different.
What is the equation for finding x again? It's x equals.
See it? Can you see the bottom of the screen? I'm going to highlight it. It's this.
Okay, yeah. So x equals.
Z times the standard deviation plus 50.
Z times.
One of
So
the problems with that formula is that it sometimes to people looks like 2 times 5 or 25.
yeah, that's what I was getting
I
confused.
know, I should do something more like this.
Yeah, that's yeah, that's what I have in my notes. I think that.
Yeah, you shouldn't have to, like when you multiply two letters together, it's supposed to be understood.
Yeah.
But they look so much like numbers that.
Okay, that makes sense. That's what I was getting confused.
Better? Okay.
Yeah, I wrote it down wrong.
I'll try to remember to do that.
That's fine.
Okay. Now we're just going to practice some more of these. And then Friday is a day that you have asynchronous. You're going, remember how I said instead of doing big tests, we're just going to do a bunch of small things? Also, I'm going to let you drop the bottom one. So I need to come up with a lot of them. And I think what I'm going to do is once a week on Fridays, assuming that we're keeping up with learning the right amount of stuff as many times as I can. On Fridays, I will give you something to work on your own time, and I can make it due on before the next class on Monday. That way you can mess around with your time the way you like and not have to be sitting in front of a screen at exactly this time. Because I don't know about the rest of you, but Heather and I just finished an hour-long class, right? And I actually have a class, usually they're not meeting today, but usually that starts again at 1:15. So basically I'm going from 10:20 through 2:15 talking too much. And I can't even imagine what it's like to just sit there quietly and take notes. And especially if your fire alarm is going off, that's a good one. Oh my God. I'm sitting here in a very quiet room. You can tell there's no other noise. I actually have a dog asleep in a bed next to me. And I have a girlfriend who's in the next room with her headphones on, being as quiet as possible. We are in a very contained 65-year-old environment. Some of you, not so much. In the last class, I had somebody playing Eagles in the background. And there's Heather with, I'm sorry, a shit show to deal with at her place.
They go back to school on Monday, so it'll be
Congratulations.
very nice.
We'll have to hear the background that day just so I can.
Oh, actually Tuesday. So Monday's screwed, but Wednesday's gonna be great.
Okay.
Yeah.
All right. Okay, I want to do I'm just going to throw some questions out there that you may need the table to answer, you may need the formula to answer, or you may need neither to answer. Given a normal curve, What z-score cuts off the top 20%? That's my first question. Given a normal curve, what z-score cuts off the top 20%? Hint, draw the picture. I'm sitting here on my laptop trying to make this picture move, but it actually moves on a different machine entirely. What z-score cuts off the top 20%? Notice I don't have to give you the mean and standard deviation. It's not the question. The question is about z-scores. Okay, somebody should have it by now. Grace, are you playing along yet, or are you just letting it be alive in there?
I'm just kind of letting it
Okay,
record and alive.
all right. Make sure you catch up somehow, Grace.
Yeah, I will.
Okay. Joe, are you playing along? Yeah, not so much. Sam, what you got? Is Sam even still here? Sam's gone, right? No, Sam's here. Sam, do you have the answer to this one? No, nobody's playing along. I'm talking to a microphone. Okay, it's either Isaac or Heather or Elijah.
They look frozen on mine, and I don't know if they are or not, but they haven't moved in a while.
Well, what did you get for
So
me?
maybe they're in and out. I got, so I looked at column C, and that would give me a z-score of 0.84.
Yes, exactly.
Okay.
So Z equals 0.84, and that's the answer to the question. They can catch this recording later. Oh, Sam's back. Were you guys frozen?
Yeah.
Yeah. I just saw your initial, but Heather said you looked frozen.
It says mine keeps flashing like unstable internet connection.
The internet in these buildings.
Yeah, mine's been fine up until today, but
You know, it's Wi-Fi. Do you have an Ethernet cable you can just plug into the wall?
I did in Meyer, but not in this room.
I think IT will bring you one. They're like determined to make things. They're like, Kim is like a woman on fire about this.
I don't know if there's a port, or else I would plug in, but
If you see one and you plan to stay there, I would ask the help desk to give you an Ethernet cable because the Wi-Fi is not
there's
stable.
gotta be one around here somewhere. I just have to find it. I thought all rooms had to have them, but I'm not sure.
I thought they did too, Sam. I thought that they had to supply an Ethernet cable to each desk after last year when students were having so much trouble with the Wi-Fi. Well,
And-
every year, but last year was particularly bad.
In most,
Okay, let's just do a couple more of these. The answer to the last one was Z equals 0.84, cuts it off. What z-score cuts off the bottom 27% of scores? What z-score cuts off the bottom 27% of scores? There's my simple picture. I've simplified it now that I know you're good at this. And by the way, good at this means you can follow the question. I know these suck. Feels completely pointless, doesn't it? Z-scores? Like busy work? They'll be done soon. They lay a foundation. Okay. Somebody besides Heather, talk us through this one. No? Isaac, you're muted in case you tried to talk.
No, well, I actually got that last problem wrong, so I'm.
Oh, all right. Let me talk us through this one. It'll be my turn. So this area down here is 27%, which is the same as saying it's 0.27. And I look at the table and I realize that it's column C that is 0.27. It's the area beyond Z, toward the edge of the curve. It's not between the mean and Z, beyond Z. So I look in the table under column C for 0.27. Sorry, I'm getting a lot of unwelcome phone calls.
So both problems you wanted to look in column C.
Yeah, so far, yeah. So 0.27, and the closest that we get to that is 0.61 z-score. So what z-score cuts off the bottom 27%? It's a negative z-score because it's below the mean. So negative 0.61 is the answer. Let's do another one. What percentage of the normal curve is between the mean and the z-score of negative 1.07? So we have a mean, we have a negative z-score of z equals negative, what did I say? 1.07. And I want to know what percentage is between the mean and that. It's green stuff. That's my, the answer is going to be there. What percentage of people? So the question becomes, what column do I need to look in
B.
find that answer? Yeah, you're right, Isaac. B.
Okay.
So I look.
Is it 35.77%?
It is. Thanks, Elijah. So the answer is, wow, 35.77%. Elijah, talk us through how you got there.
Well, you said that negatives don't matter when you're looking at a z-score, so I found 1.07 in column A on the table.
Yep, that's the z-score. So you find 1.07. I'm with you.
And then I looked in column B and moved the decimal over 2 places.
Right. In column B, you find 0.35770. So you moved it over to answer for percentage, and you get 35.77%. Now, I want to be really clear about z-scores, positive and negative, what matters. When you're looking for area, there's no such thing as negative area. So a negative z-score just tells you that it's below the mean. And you use the same table to find area. But z-scores matter a great deal when you're trying to come up with scores.
Mm-hmm.
Because if the score is -1 z-scores, if the z-score is -1 and you're trying to come up with the score, it's going to be below the mean. You're going to have to remember to use that negative.
Mm-hmm.
Okay, so you have to be careful Keep it in formulas, but don't ever talk about negative numbers of people or negative area. I actually had a student on an exam one time tell me that negative, I don't know, 3.77 people did something, and I was like, wow, that's very interesting. Wonder what else these non-people can do. Let me see if I have any more really kind of simple, just need the table stuff. I think that's good enough for Z-scores, to tell you the truth. You have a gazillion worksheets there. I gave you as many as I could find from my old notes, Teaching Fellows' old notes, and online sources. So use them. I'm going to post what I guess we're just going to call these quizzes. I'm going to post that one by tomorrow at the latest, probably by the end of today. I have to post one for social and for this one, so I'll probably just sit here and do them both right after this class. And then I'll make them due by Monday before class. I'll make this one due. So we're not meeting on Friday. We're spending the time working on the quiz, which means you should spend any kind of time that you might ever devote toward homework studying on some of those practice problems. It's open book, open note, and open trust. I'm hoping that you have the only formulas that you need, which I'll put in the notes here so you have them. X equals Z minus, I'm so sorry. I'm taking all that back. Okay, starting over. X equals Z times the standard deviation. Thank you for that, Sam. Plus the mean. And Z equals X minus the mean. Put that over the standard deviation. Okay, those are S's, not 5s. It's really hard to tell. Mine look exactly the same as each other, but it's all letters. Okay, those are the formulas that you should need to do. I mean, you might need this. You might need the mean equals the sum of the scores over n, and you might need the formula for standard deviation, but don't forget, you now know how to get your calculator to do this part. Those are all the formulas we've got so far, as far as I can remember. Okay, so you could need any and all of these, or you could, yeah, that's it. That's what I wanted to say. I'm going to take a screenshot. Whoops.
I actually have one quick question. On the calculator, it's omega, right? The standard deviation.
Yeah, on some calculators it's omega, on some it's S. On some it's omega minus 1. And on some it's S minus 1. If you have the formula that gives you the minus 1, if your calculator does that, use that one. But if it just says omega and you don't have omega minus 1, use the omega. Okay? All that that's referring to, by the way, is this. It's referring to the denominator here. If you're talking about a population, you typically use a form, not you, the rest of the world, not class, but like computer software. If it's talking about a population, it usually just has n. If it's talking about a sample, it usually has n minus 1. It's considered mathematically conservative for an experiment so that you don't overgeneralize your results. It's complicated, but that's what that's referring to. Okay, so if it says minus 1, that means that we're working with a sample. And for the purposes of this course, whichever one your calculator does, I'll take it. I'll double check to make sure I have both numbers when I'm grading stuff so that I don't downgrade you just because I have, all of mine are minus 1, but I'll go check the ones that aren't. You should be fine. We're good? Okay. Give me like half an hour to eat some lunch, take a walk, and then I will get some things posted for you. Okay, and those of you who have me for 2 classes, actually any other, now I have no classes meeting on Friday, 0. So you're gonna need to let me know if you wanna meet with me for something, because there's no scheduled times, but I'm home, I'm available, I'm gonna be grading stuff. So I can just as easily open up a window and talk to you. All right, be good, you guys, take care.
Thank you.
Have a good day.
You too.